Hello there. Welcome to a peaceful night with 5 minutes fall to sleep. Let me stay with you in this final moment of your long day. Now, let your shoulders relax. Let your body loosen. Let your eyes close or drift softly towards some distant point. No need to think anymore. Just breathe and let your mind drift. Drift gently through the vastness of space. Tonight, we won't go too far. We will simply float. Float across our solar system. From the warm light of the sun to the distant planets cold and silent, each moment one small truth. Each story like a gentle wave, lulling sleep to come. And before we begin, if you feel a bit of peace in this place, please press like and subscribe so that other sleepy souls can also find their way here on some night when they need it. Now then, close your eyes and come with me. Let's begin the journey. We begin at the center with our star, the sun, a massive sphere of burning hydrogen and helium. It has been burning for more than 6 billion years and will continue for billions more. Every passing second, the sun transforms 600 million tons of hydrogen into helium through nuclear fusion. The energy released is equivalent to 100 billion atomic bombs exploding at once. This number may sound terrifying, but it is the very source of life for everything on Earth. Light from the sun's core takes more than 100,000 years to reach its surface because it must collide with countless particles, bouncing around like in a giant maze. But once it escapes the surface, it takes only 8 minutes for that light to reach Earth. Strange, isn't it? The sunlight you saw this morning began its journey in the ancient past, when it was still trapped inside the star. When those photons were born, our ancestors may still have been hunter-gatherers, unaware of agriculture or writing. And now, after an unimaginably long journey, they finally reach you, warming your skin, nurturing the plants around you. The sun makes up 99.8% of the total mass of the solar system. All the planets, moons, asteroids, and comets combined make up only the remaining 0.2%. It is a colossal star with a diameter of more than 1.4 million kilometers, large enough to hold over 1 million Earths inside. At the sun's core, the temperature reaches more than 15 million degrees Celsius. The pressure there is 250 billion times greater than Earth's atmospheric pressure. Under these extreme conditions, hydrogen nuclei collide and fuse into helium, releasing enormous amounts of energy. This is the energy that sustains the sun and sustains us. Now, take a deep breath. Feel your breath, gentle and steady. And let me guide you farther away, out of the warm sunlight, into the darkness of space. First is Mercury, the smallest planet and the one closest to the sun in the solar system. This is a very lonely world, with no moon orbiting it and no atmosphere to retain heat. It has only a thin, ghost-like layer called an exosphere, a faint gas envelope that dissipates into space. Without an atmosphere, temperatures on Mercury vary drastically. During the day, when sunlight hits directly, temperatures can reach 430 degrees Celsius, hot enough to melt lead and zinc. But at night, When Mercury's dark side turns away from the sun, temperatures drop to minus 180 degrees Celsius, a difference of more than 600 degrees between day and night, one of the most extreme temperature variations in the solar system. One interesting fact about Mercury is the way it rotates. A day on Mercury, the time it takes to rotate once on its axis, is longer than its year, the time it takes to orbit the sun. Strange, isn't it? A single day there lasts 59 Earth days, while a year lasts only 88 Earth days. Imagine standing on Mercury's surface. You see the sun slowly rising in the east, but instead of continuing across the sky, it stops, reverses direction, then rises again. Afterward, it continues its path across the sky for many days before finally setting in the west. As if time itself becomes hazy and uncertain on this tiny world. Mercury's surface is full of impact craters, much like our moon. Without an atmosphere to burn up meteoroids, every collision leaves a mark. Some craters are hundreds of kilometers wide, created by massive impacts in the distant past. Take another deep breath. Feel the calm, and we drift on, leaving behind this scorching yet frozen world. Now, we come to Venus, the brightest planet in our night sky. Beautiful from afar, shining like a white gem, but up close, it is a true hellscape. Venus rotates in the opposite direction of most other planets. While Earth, Mars, Jupiter, and most planets rotate counterclockwise when viewed from the North Pole, Venus rotates clockwise. No one knows exactly why, but it may have been caused by a colossal impact in the distant past that flipped its rotation. And Venus rotates very slowly. One day on Venus is longer than its year. A single day lasts 243 Earth days, while a year lasts only 225 Earth days. Similar to Mercury, but even more extreme. The surface of Venus reaches 465 degrees Celsius, hotter than Mercury, even though it is farther from the sun. Why? Because its atmosphere is dense and full of CO2, creating the strongest greenhouse effect in the solar system. This atmosphere is so thick that the surface pressure is 90 times that of Earth, equivalent to the pressure at a depth of nearly 1 kilometer under the Earth's ocean. Sulfuric acid rain falls from the yellow clouds about 50 kilometers above the surface. But because the temperature is too high, these droplets evaporate midway and never touch the ground. Only the upper cloud layers have real rainfall. Venus has no magnetic field, no shield against the solar wind. This means the solar wind, a stream of charged particles from the sun, strikes directly at the upper atmosphere of Venus. Over time, this has caused Venus to lose much of the water it once had. Scientists believe that long ago, Venus may have had oceans, but the increasing greenhouse effect caused the water to evaporate, and the hydrogen was carried away into space by the solar wind. Venus also has no moon. Like Mercury, it orbits the sun alone, a solitary and harsh world. But from afar, viewed from Earth, Venus is still beautiful. It shines brightly like a white gem, the brightest object in the sky after the sun and the moon. In ancient times, people called it the morning star when it appeared at dawn, and the evening star when it appeared at dusk. Sometimes, beauty is only an illusion. Breathe out, breathe in, feel your breath. And we return home to our blue planet. Here it is, Earth, the only planet we know that hosts life. Among the thousands of exoplanets discovered, not one has shown definitive signs of life. Earth remains the only truly special place. Earth has water in all three states: solid, liquid, and gas. Ice at the poles and on mountain peaks, liquid water in oceans, rivers, and lakes, and water vapor in the atmosphere. The presence of liquid water is an essential condition for life as we know it. Earth's atmosphere is just thick enough to retain heat and protect us from harmful radiation. It contains 78% nitrogen, 21% oxygen, and small amounts of other gases such as CO2 and argon. The ozone layer in the atmosphere absorbs most of the harmful ultraviolet rays from the sun, protecting life on the surface. Earth has a strong magnetic field, generated by the flow of molten iron in its outer core. This magnetic field acts as a shield, blocking the solar wind and cosmic rays. Without this magnetic field, our atmosphere would be stripped away gradually, similar to what happened to Mars. Something few people know is that Earth is the only planet with plate tectonics. Earth's crust is divided into large plates that float on the molten mantle below. These plates drift and collide, creating mountains and oceans. This cycle reshapes the surface and sustains life by recycling chemical elements and regulating the climate. And the moon, our moon, is very large compared to its parent planet. It has a diameter of about 3,474 kilometers, roughly 1/4 of Earth's diameter. This ratio is extremely large compared to most moons in the solar system. The moon creates tides in our oceans. Its gravitational pull draws the seawater, creating two bulges, one on the side facing the moon and one on the opposite side. As Earth rotates, these bulges move, creating two high tides and two low tides each day. The moon also stabilizes Earth's axial tilt. Thanks to it, we have 4 distinct seasons and a stable climate. Without the moon, Earth's axis would wobble significantly over time, causing extreme climate variations. But the moon is slowly moving away from us. Each year, it recedes by about 3.8 centimeters. The reason is that Earth's rotational energy is transferred into the moon's orbital momentum through tidal forces. One day, far in the future, the moon will be so distant that it will no longer create total solar eclipses. From Earth, it will appear smaller than the sun. But tonight, the moon is still there, glowing softly in the sky, like a quiet companion that has stayed with us for billions of years. Close your eyes, feel the serenity, and let us fly even farther. Next is Mars, the red planet, a cold desert filled with wind and dust. Mars is smaller than Earth, with a diameter only about half as large and a mass only about 1/10. Mars has 2 small moons, Phobos and Deimos, named after the two sons of the war god Ares in Greek mythology. Both are tiny and irregularly shaped, resembling large rocks more than spheres. Scientists believe they may once have been asteroids captured by Mars's gravity. Phobos, the larger moon, is slowly falling toward Mars. Each century, it comes about 1.8 meters closer. One day, around 50 million years from now, it will be too close and will break apart due to tidal forces, forming a ring around Mars, similar to Saturn's rings. The surface of Mars features spectacular landscapes. There is the Valles Marineris Canyon, more than 4,000 kilometers long, longer than the entire United States, and up to 7 kilometers deep. If placed on Earth, it would stretch from New York to California. It is the largest canyon in the solar system, likely formed by the cracking of the crust as the planet cooled. And then there is Olympus Mons, a volcano 21 kilometers tall, 3 times the height of Mount Everest, and as wide as the entire state of Arizona. It is the largest volcano in the solar system. It could grow so large because Mars has no plate tectonics. On Earth, when a volcano forms, the tectonic plate moves, and the volcano is carried away from its magma source. But on Mars, the crust is fixed, allowing magma to accumulate in one place for millions of years, building an enormous mountain. But now, Mars is silent. No more volcanic eruptions, no more flowing water on the surface. Only wind and red dust remain. Mars's atmosphere is extremely thin, only about 1% of Earth's atmosphere, composed mostly of CO2. The atmospheric pressure is so low that liquid water cannot exist on the surface. If there were water, it would either boil instantly or freeze. Scientists believe that long ago, Mars once had oceans and a thicker atmosphere. There is much evidence that water once flowed on the surface. Dry valleys, meandering channels, and minerals that form only in water. But without a magnetic field, the solar wind stripped away the atmosphere over billions of years, and the water either evaporated or froze beneath the ground. Now, only traces remain, dry channels, salt plains, like memories of a dead world, or perhaps one merely sleeping, waiting for a day to be awakened. Slow your breath, feel the stillness, and we pass through the asteroid belt toward the giants. Jupiter, the largest and most powerful of all the planets. It is 318 times the mass of Earth, and so enormous that it could hold more than 1,300 Earths inside. Jupiter has more than 90 moons, a very large family. The 4 largest moons, discovered by Galileo Galilei in 1610, are Io, Europa, Ganymede, and Callisto. They are known as the Galilean moons. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It has a diameter of 5,268 kilometers and is the only moon with its own magnetic field. Beneath its thick, icy surface, Ganymede may host a salty ocean larger than all of Earth's oceans combined. Europa is an icy world with a smooth surface and few impact craters. This suggests its surface is relatively young, renewed by geological activity. Beneath a layer of ice 15 to 25 kilometers thick may lie a salty ocean deeper than all of Earth's oceans. This water is kept liquid by tidal heating generated by Jupiter. Sometimes Europa has fractures, cracks spreading outward from within. Water from the subsurface ocean erupts through these cracks, all the way into space, like enormous geysers. NASA spacecraft have detected water vapor erupting from Europa, confirming the existence of its subsurface ocean. If there is life in Europa's subsurface ocean, it would live in complete darkness, without sunlight. It might survive around hydrothermal vents on the seafloor, similar to the organisms found in the deep oceans of Earth, where sunlight never reaches, but life still thrives. Io is the most volcanically active body in the entire solar system. Its surface is covered with sulfur and sulfur compounds, giving it its characteristic yellow, orange, and red colors. Io is stretched and compressed by the gravity of Jupiter and the other Galilean moons, constantly distorted like a rubber ball. This deformation generates enormous heat inside, giving Io hundreds of active volcanoes. Io's surface is always renewing, always restless. Volcanoes eject lava hundreds of kilometers high. It is never quiet. This is the most intense place in the solar system, a volcanic hellscape in endless turmoil. Callisto is the oldest moon, with a surface full of impact craters like a record of time. It has changed little over billions of years, preserving the history of the solar system from its earliest days. And Jupiter itself has the Great Red Spot, a storm twice the size of Earth that has existed for at least 300 years, perhaps longer. It is a high-pressure region spinning counterclockwise, with winds reaching 400 kilometers per hour. Its red color may come from complex chemical compounds created by ultraviolet light from the sun. Jupiter has the strongest magnetic field in the solar system, 20,000 times stronger than Earth's. Its magnetosphere extends millions of kilometers, so large that if we could see it from Earth, it would appear bigger than the moon in the sky. This magnetic field traps charged particles from the solar wind and from Io, forming radiation belts that are extremely dangerous to any spacecraft passing through. Another remarkable fact is that Jupiter emits its own light. It does not only reflect sunlight, it also releases energy from within. Jupiter radiates more energy than it receives from the sun, about 1.6 times more. This energy comes from leftover heat from its formation and from the slow contraction of the planet. It is like a star that almost became one, but was not massive enough to begin nuclear fusion. Relax, feel your breath, and we glide to the next ringed world, Saturn, the Lord of the Rings. Saturn, the most beautiful of the planets, with its shimmering rings encircling it. These rings are made of ice, billions, trillions of ice particles, ranging from the size of dust grains to the size of houses, even buildings. But the rings are very thin, only about 10 meters thick, even though they span up to 280,000 kilometers in diameter. Compared to their enormous diameter, the rings are as thin as a sheet of paper. If you could look at the rings edge on, you would hardly see anything at all, and the rings are disappearing. Ice is falling into Saturn like invisible icy rain, called ring rain. Each second, Saturn loses tons of ring material. In about 100 million years, the rings may vanish entirely. We are lucky to live in a time when we can still see them. At Saturn's North Pole lies a hexagonal storm, an eerily perfect shape. Each side of this hexagon is about 13,800 kilometers long, larger than Earth's diameter. This storm has been observed since the 1980s and still persists today. No one knows exactly why it is hexagonal, but scientists believe it results from complex interactions between atmospheric jet streams moving at different speeds. Saturn also had many moons, more than 80 confirmed, with many smaller ones still awaiting discovery. Each moon has its own story, its own features. Titan is the largest and most fascinating moon of Saturn. It is the only moon in the solar system with a thick atmosphere, even thicker than Earth's. Titan's atmosphere is mostly nitrogen, like Earth's, but it also contains methane and complex hydrocarbons. Titan has lakes and rivers, but not of water, of liquid methane and ethane. Titan's surface is minus 179 degrees Celsius, cold enough for methane to exist as a liquid. There is methane rain, a methane hydrological cycle similar to Earth's, but with methane instead of water. There are large lakes at the poles and dry channels showing past flows. Titan's surface is hidden beneath thick orange clouds made of complex hydrocarbon molecules. Sunlight at Titan is only about 1% as bright as on Earth, like a permanent, dim sunset. But underground, deep beneath the ice, there may be a hidden ocean of water kept liquid by heat from the core and tidal forces. Enceladus is a small icy moon, only about 500 kilometers in diameter. But from its south pole erupt giant plumes. Water from a subsurface ocean shoots through fissures in the ice, called tiger stripes. These jets blast into space at hundreds of meters per second, forming a cloud of ice around Enceladus. NASA's Cassini spacecraft flew through these plumes and analyzed their composition. It found water, salts, organic molecules, and even complex molecules such as amino acids. These are essential ingredients for life as we know it. Perhaps within Enceladus's hidden ocean, in complete darkness, simple forms of life may exist. Take a deep breath again. Feel the peace spreading through your body, and we fly farther still, leaving the shimmering ringed world behind. Uranus, a very strange planet, different from all the others. It rotates tilted at 98 degrees, meaning its axis is almost horizontal relative to its orbital plane, as if it were rolling around the sun rather than spinning like other planets. Perhaps long ago, during the formation of the solar system, Uranus was struck by a massive object, possibly Earth-sized, and was knocked over. Or perhaps multiple smaller impacts over time gradually tilted its axis. Whatever the cause, the result is a planet with extreme seasons. Because of its sideways tilt, each pole of Uranus experiences 42 years of continuous sunlight, followed by 42 years of continuous darkness. Imagine a day lasting 42 years, then a night lasting 42 years. While one pole faces the sun, the other pole plunges into complete darkness. The climate on Uranus is likely very unusual, with extreme temperature variations between hemispheres. Uranus is pale blue because its atmosphere contains methane. Methane absorbs red light and reflects blue light, giving the planet its characteristic color. Its atmosphere is mostly hydrogen and helium, with small amounts of methane and hydrocarbons. And there is speculation that deep within Uranus and Neptune, diamond rain may exist. The high pressure and temperature deep inside these planets can break methane apart into carbon. This carbon is then compressed into diamond under immense pressure. These diamonds, possibly the size of peas or larger, fall like rain in the darkness, accumulating in layers around the core. Strange, isn't it? A diamond rain we can never see, occurring inside a distant planet. The universe is full of such wonders, phenomena far beyond our imagination. Uranus has 27 known moons. Unlike most moons in the solar system named after Greek and Roman mythology, Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope. There are Miranda, Ariel, Umbriel, Titania, Oberon, and many others, each carrying a literary story. Miranda is one of the strangest moons. Its surface has entirely different terrains, as if pieced together from several different worlds. There are cliffs as high as 20 kilometers, twice the depth of the Grand Canyon. Scientists believe Miranda may have been shattered by a massive impact and then reassembled in a random mosaic. Breathe gently. Feel relaxation in every muscle. And we arrive at the final planet in our journey. Neptune, the farthest, coldest, and bluest of the planets. It is 30 times farther from the Sun than Earth. So far, that sunlight there is only 1/900th as bright as on Earth. Neptune has a deeper blue color than Uranus, also due to methane in the atmosphere, but possibly because of other unidentified compounds that make it darker. Neptune's atmosphere is very dynamic, with powerful storms and the fastest winds in the solar system. Neptune emits more heat than it receives from the Sun, about 2.6 times more. Like Jupiter, Neptune has internal heat, possibly from the slow contraction of the planet or from chemical processes deep within. This energy drives the violent weather on Neptune. The winds on Neptune can reach speeds up to 2,100 kilometers per hour, faster than the speed of sound in air. These are the fastest winds ever measured in the solar system. Why a distant, frigid planet like Neptune has such powerful winds remains a mystery. Huge storms appear and vanish on Neptune. When Voyager 2 flew past in 1989, it discovered a large storm called the Great Dark Spot, roughly the size of Earth. But when the Hubble Space Telescope observed Neptune in 1994, the Great Dark Spot had disappeared. Storms on Neptune seem to persist for a few years and then dissipate, unlike Jupiter's Great Red Spot, which has existed for centuries. Neptune was discovered not by direct observation, but by mathematics. Astronomers noticed Uranus deviating from its predicted orbit, as if something were tugging on it. They calculated and predicted the position of an unknown planet, and when they pointed telescopes there, they found Neptune. This is one of the great triumphs of theoretical science, demonstrating the power of mathematics to understand the universe. Neptune has 14 confirmed moons. The largest is Triton, a very special moon. Triton orbits in the opposite direction to Neptune's rotation, a very rare occurrence. Most large moons orbit in the same direction as their parent planet. This implies Triton did not form with Neptune. It was not born from the same disk of material that formed Neptune. Instead, Triton was likely an independent object, perhaps a dwarf planet from the Kuiper belt, that was captured by Neptune's gravity when it passed too close. And Triton is slowly falling toward Neptune. Its orbit is gradually shrinking. One day, in about 6 billion years, Triton will come too close and be torn apart by tidal forces, forming a new ring, possibly even more beautiful than Saturn's rings. On Triton, there are cryovolcanoes. Instead of erupting hot lava, as on Earth, Triton's volcanoes erupt liquid nitrogen, methane, and water. These plumes can reach heights up to 8 kilometers, forming thin clouds above the icy surface. Triton's surface is among the coldest places in the solar system, with temperatures around minus 235 degrees Celsius. Yet even in this extreme cold, there is geological activity. A frigid world, but still dynamic and evolving. And now, we have traversed all the planets, from nearby Mercury to distant Neptune. We have seen scorching and frozen worlds, planets with thick atmospheres, and planets with none, moons with subsurface oceans, and moons with erupting volcanoes. Take a deep breath again. Feel the vastness of space, the silence of the cosmos. In space, there is no sound, no air to carry pressure waves, only light and darkness, only absolute silence. Each planet is a world. Each world has its own story. Each moon is a mystery, a question waiting to be answered. And we, small humans on Earth, are slowly uncovering those mysteries. We are here, on Earth, the only place we know that harbors life, a small planet orbiting an ordinary star in a galaxy containing hundreds of billions of other stars. How fortunate, isn't it? But the solar system is not limited to 8 planets. There are countless smaller worlds, asteroids, dwarf planets, comets. Each object carries a piece of the solar system's history. Between the orbits of Mars and Jupiter lies the asteroid belt, containing millions of asteroids. These are leftover fragments from the solar system's formation, rocks and metals that never coalesced into a planet. Jupiter's immense gravity prevented them from accreting, causing collisions, fragmentation, and a long-term dispersal over 4.6 billion years. Ceres is the largest object in this belt, and the only dwarf planet within the asteroid belt. It has a diameter of about 940 kilometers, large enough for gravity to pull it into a spherical shape. Beneath its rocky surface, Ceres may harbor a salty ocean. NASA's Dawn spacecraft detected bright spots on its surface, thought to be salt deposits evaporated from subsurface water. Vesta is the second largest asteroid, with a structure resembling a small planet, a metallic core, a mantle, and a rocky crust. Vesta's surface hosts an enormous impact basin that nearly covers one hemisphere. Some asteroids even have their own moons. Ida, an asteroid roughly 56 kilometers long, has a small moon named Dactyl. Many asteroids are not monolithic rocks, but rubble piles, loose aggregates of fragments held together by weak gravity. Comets are balls of ice, dust, and rock traveling on elongated orbits. Most originate from two regions, the Kuiper belt just beyond Neptune's orbit, and the Oort cloud, a vast shell surrounding the entire solar system at nearly 1 light-year from the Sun. When a comet approaches the Sun, solar heating causes its ices to sublimate, forming a coma of gas and dust around the nucleus. Solar radiation pressure and the solar wind blow this material into a long, luminous tail. A comet's tail always points away from the Sun, regardless of the comet's direction of travel. Halley's Comet is one of the most famous. It orbits the Sun every 76 years and has been recorded since antiquity. The Chinese documented it as early as 240 BCE. Its most recent appearance was in 1986, and the next will be in 2061. Each time Halley passes, it leaves a stream of dust along its orbit. When Earth passes through these dust trails, we observe meteor showers. In May, we see the Eta Aquariids, and in October, the Orionids, both originating from Halley's debris. The Oort cloud contains trillions of comets at the farthest edge of the solar system, where the Sun's gravity is almost negligible. Occasionally, a passing star perturbs the gravitational balance and sends some comets inward. These comets take millions of years to travel into the inner system, and when they arrive, they carry information from the solar system's primordial era. Beyond Neptune's orbit lies the Kuiper belt, a vast region containing hundreds of thousands of icy bodies. Pluto, once considered the 9th planet, is now classified as a dwarf planet and is one of the Kuiper belt's most famous residents. Pluto has 5 moons. The largest, Charon, is nearly half Pluto's size. In fact, Pluto and Charon function more like a double-planet system than a planet-moon pair. They orbit a barycenter located outside Pluto's surface. Pluto's surface is surprisingly diverse. There are icy mountains thousands of meters high and nitrogen plains hundreds of kilometers across. There are dark and bright regions, faults, and sinkholes. NASA's New Horizons flyby in 2015 returned breathtaking images showing a far more complex and beautiful world than expected. On Pluto, there is a giant heart-shaped region named Tombaugh Regio, in honor of Clyde Tombaugh, who discovered Pluto. One half of this heart, called Sputnik Planitia, is a smooth plain composed of condensed nitrogen. This nitrogen appears to flow very slowly, like an immense glacier. Eris is another dwarf planet, slightly larger than Pluto. Its discovery, in 2005, sparked the debate over the definition of a planet and led to Pluto's reclassification. Eris orbits the Sun at nearly twice Pluto's average distance, in a very remote and frigid region. Makemake and Haumea are also dwarf planets in the Kuiper belt. Haumea has an unusual elongated shape, an ellipsoid, because it rotates extremely rapidly, completing a rotation in just 4 hours. This fast spin stretches Haumea into an oval shape. Scientists estimate there are hundreds more undiscovered dwarf planets in the Kuiper belt and beyond. Each new discovery teaches us more about the history and structure of the solar system. Breathe deeply. Let your body relax completely. Imagine yourself floating in space far from Earth, looking down at our little blue planet. You see city lights sparkling in the darkness. You see the oceans reflecting sunlight, You see clouds drifting slowly across continents, and all around you is absolute silence. No sound in space, no wind blowing, no waves crashing. Only silence, the deepest silence you can imagine. But within that silence, there is beauty. There is peace. You see stars glittering everywhere, thousands, millions of stars. Each star is a sun, possibly with its own planets and perhaps its own life. You see the Milky Way stretching across the sky, a faint band of light formed by billions of stars. You are part of this galaxy, part of the vast universe, and you feel fortunate to be born on Earth, the only place we know that supports life. Fortunate to live at this time, when humanity has begun to explore space and understand its place in the cosmos. We have traversed all the planets, from nearby Mercury to distant Neptune, but the journey is not over. Now, return to where everything began, back to the heart of the solar system, to our star. The sun is not merely a bright sphere in the sky. It is the reason we exist, the source of energy that nourishes all life on Earth. Every second, the sun fuses 600 million tons of hydrogen into helium via nuclear fusion. The energy released is equivalent to 100 billion atomic bombs detonating simultaneously. Yet the miracle is, we are not incinerated. The distance of 150 million kilometers between the sun and Earth is just right for light and heat to reach us gently, sustaining life rather than destroying it. In the process, the sun loses millions of tons of mass every second. This sounds enormous, but relative to its total mass, it is an infinitesimal fraction. The sun makes up 99.8% of the total mass of the solar system. All the planets, moons, asteroids, and comets combined account for only the remaining 0.2%. Most of the sun is hydrogen and helium, the two simplest elements in the universe. But when compressed under extreme pressure and temperature, they generate the greatest source of energy we know. At the sun's core, the temperature reaches more than 15 million degrees Celsius. The pressure there is 250 billion times Earth's atmospheric pressure. Under these extreme conditions, hydrogen nuclei collide at tremendous speeds and fuse into helium. The light produced by this reaction cannot escape immediately. It is trapped inside the sun, colliding with countless particles, bouncing around like a ball in a gigantic maze. It takes more than 100,000 years for a photon of light from the core to find its way to the surface. But once it escapes, it needs only 8 minutes and 20 seconds to cross space and touch your skin. This means the sunlight you feel today began its journey in the final stone age of humankind. When that light was first born in the sun's interior, our ancestors were still hunter-gatherers, unaware of agriculture and writing, and now, after a long voyage, it finally reaches you. The sun's surface is not a solid layer. It is a boiling sea of plasma, constantly moving and changing. Scientists have discovered that the sun's surface vibrates like a gigantic musical instrument. Sound waves generated by internal convection propagate throughout the star, producing small oscillations. This field of study is called helioseismology, the study of solar quakes. By measuring these oscillations, Scientists can peer inside the sun and understand its structure and dynamics without digging or drilling. The sun's visible surface, the photosphere, has a temperature of about 5,500 degrees Celsius. Yet, as you move outward into the corona, the temperature soars to millions of degrees. This is one of the greatest mysteries of solar physics. How can an atmospheric layer far from the heat source be hotter than the surface? Scientists believe the sun's magnetic field plays an important role. Magnetic field lines become twisted and braided, then suddenly break, releasing enormous amounts of energy as heat. But the exact details remain an active area of research. If you view the sun through a special filter, you will see dark patches on the surface. These are sunspots. They are not truly black, only darker than the surroundings because their temperature is about 1,500 degrees lower than the rest of the surface. Sunspots form in regions of extremely strong magnetic field, strong enough to inhibit convective motion of plasma and cool the area. The number of sunspots is not constant. It varies on a cycle of roughly 11 years. At solar maximum, the surface is covered with sunspots. Magnetic fields are strong, and solar activity is intense. At solar minimum, the surface is almost smooth, with few sunspots and quieter activity. Interestingly, every approximately 11 years, the sun's magnetic field reverses polarity. The magnetic north becomes the magnetic south, and vice versa. After 22 years, it returns to its original state. This cycle affects not only the sun, but also Earth. When the sun is active, it launches more solar storms. Streams of plasma and charged particles hurled into space at speeds of millions of kilometers per hour. When these storms reach Earth, they interact with our magnetic field, producing spectacular aurora at high latitudes. They can also disturb satellites, communication systems, and even power grids. In 1859, one of the strongest recorded solar storms, the Carrington event, struck Earth. Auroras were observed as far toward the tropics as low latitudes. Telegraph lines caught fire. Fortunately, society then relied little on electrical technology. If a similar event occurred today, damages could reach into the trillions of dollars. The sun emits more than light. It continuously emits a stream of charged particles called the solar wind. These particles, mainly protons and electrons, are ejected from the corona at speeds of hundreds of kilometers per second. The solar wind blows in all directions, forming a gigantic bubble around the solar system called the heliosphere. The boundary of the heliosphere, where the solar wind collides with the interstellar medium, is called the heliopause. In 2012, Voyager 1 crossed this boundary, becoming the first human-made object to leave the solar system and enter interstellar space. Voyager 2 followed in 2018. Both spacecraft continue to send signals back to Earth, informing us about the environment out there, where sunlight no longer dominates and true interstellar space begins. Each Voyager carries a golden record. On it are recorded sounds of Earth: the surf, bird song, children laughing, music from many cultures, and greetings in 55 languages. It is a message to any civilization that might find it in some distant future. In a way, these records are proof that we existed and that we reached out to the stars. The sun cannot burn forever. It has existed for 6 billion years and has roughly 5 billion years of fuel left. When hydrogen in the core is exhausted, fusion will slow. The sun will begin to burn helium instead of hydrogen. It will then expand, becoming a red giant large enough to engulf Mercury, Venus, and possibly Earth. Earth's atmosphere will evaporate. The oceans will boil. Life as we know it will no longer exist. But that is far in the future. For billions of years yet, the sun will continue to shine, warm, and sustain life. After the red giant phase ends, the sun will shed its outer layers, producing a bright planetary nebula. The remaining core will contract into a white dwarf, a hot but small sphere roughly Earth-sized, yet bearing the mass of the sun. It will be too low in mass to sustain nuclear fusion. It will glow from residual heat and gradually cool over billions of years, eventually becoming a black dwarf, the cold remnant of a dead star. But tonight, the sun is still there, shining and warm. And that is all we need to know. Between the orbits of Mars and Jupiter lies a vast belt containing millions of asteroids. They are the remnants of the solar system's formation, fragments of rock and metal that never coalesced into a planet. Jupiter's enormous gravity prevented them from accreting, causing collisions, fragmentation, and dispersal over 4.6 billion years. Ceres is the largest object in this belt. It is large enough to be classified as a dwarf planet. Ceres has a diameter of about 940 kilometers and is roughly spherical due to its own gravity. Beneath its rocky surface, Ceres may harbor a salty ocean. NASA's Dawn spacecraft detected bright spots on Ceres' surface, thought to be salts evaporated from subsurface water. If this is true, Ceres could be a potential environment for microbial life. Vesta is the second largest asteroid. It has a structure similar to a small planet, with a metallic core, a mantle, and a rocky crust. Vesta's surface has an enormous impact crater that nearly covers an entire hemisphere of the asteroid. This impact launched countless fragments into space, some of which eventually fell to Earth as meteorites. Some asteroids even have their own moons. Ida, an asteroid about 56 kilometers long, has a small moon named Dactyl. Many asteroids are not solid monolithic rocks. They are merely rubble piles, loose fragments held together by weak gravity. If you stood on such an asteroid and jumped hard enough, you could escape its gravity and float into space. Comets are balls of ice, dust, and rock that travel on long orbits. Most come from two regions: the Kuiper Belt, located just beyond Neptune's orbit, and the Oort cloud, a gigantic shell surrounding the entire solar system, nearly 1 light-year from the Sun. When a comet approaches the Sun, the heat causes its ice to vaporize, creating a cloud of gas and dust around the nucleus. The pressure from sunlight and the solar wind blows this material backward, forming a long, bright tail. A comet's tail always points away from the Sun, regardless of which direction the comet is moving. Some comets have two tails, a curved white dust tail and a straight blue ion tail. Halley's Comet is one of the most famous comets. It orbits the Sun every 76 years and has been observed since ancient times. Its most recent appearance was in 1986, and its next will be in 2061. Each time Halley passes, it leaves a trail of dust along its orbit. When Earth crosses these dust streams, we see meteor showers, such as the Eta Aquarids in May and the Orionids in October. The Oort cloud contains trillions of comets. They lie at the most distant edge of the solar system, where the Sun's gravity is nearly negligible. Occasionally, a star passing near the Oort cloud can disturb the gravitational balance, sending some comets inward. These comets take millions of years to travel to the inner system, and when they arrive, they carry information from the early formation of the solar system. Beyond Neptune's orbit lies the Kuiper Belt, a vast region containing hundreds of thousands of icy objects. Pluto, once considered the ninth planet, is now classified as a dwarf planet and is one of the most well-known residents of the Kuiper Belt. Pluto has 5 moons. The largest, Charon, is nearly half the size of Pluto. In fact, Pluto and Charon resemble a double planet system rather than a planet and moon. They orbit a central point located between them. Pluto's surface is surprisingly diverse, with ice mountains, solid nitrogen plains, and a thin atmosphere. Eris is another dwarf planet, even slightly larger than Pluto. Its discovery in 2005 sparked the debate that led to Pluto's reclassification. Makemake and Haumea are also dwarf planets in the Kuiper Belt. Haumea has a very unusual shape, like an elongated ellipsoid, because it rotates extremely rapidly, completing a rotation in just 4 hours. Scientists estimate there are hundreds more dwarf planets yet to be discovered in the Kuiper Belt and beyond. Some astronomers believe there may be a large planet called Planet 9 or Planet 10, hidden at the far edge of the solar system. They propose this based on the strange orbits of several Kuiper Belt objects, which seem to be influenced by the gravity of a large unseen body. If Planet 9 exists, it could be 5 to 10 times the mass of Earth and take thousands of years to orbit the Sun. For centuries, people believed that planets moved in perfect circular orbits. But in the early 17th century, German astronomer Johannes Kepler discovered that the actual orbits are ellipses. The Sun is not at the center of the ellipse, but at one of its foci. Kepler's first law states that planets move in elliptical orbits with the Sun at one focus. The second law states that a planet moves faster when it is closer to the Sun and slower when it is farther away. The third law relates orbital period to average distance from the Sun. The farther a planet is, the longer its orbital period. These laws accurately describe planetary motion and laid the groundwork for Newton's theory of gravitation. But Mercury's orbit showed a small anomaly. The closest point of Mercury's orbit to the Sun, called perihelion, slowly shifts over time. This shift could not be fully explained by Newtonian mechanics. In 1915, Albert Einstein resolved this mystery with the theory of general relativity. He showed that the Sun's enormous mass warps space and time around it, and this effect is especially strong near the Sun. Mercury's orbit was the first observational confirmation of general relativity. We have discussed Jupiter, but one remarkable detail remains: its magnetic field. Jupiter has the strongest magnetic field in the solar system, nearly 20,000 times stronger than Earth's. Jupiter's magnetosphere, the region dominated by its magnetic field, extends millions of kilometers toward the Sun and stretches behind Jupiter all the way to Saturn's orbit. This magnetic field traps charged particles from the solar wind and from Jupiter's moons, especially Io. Io releases sulfur dioxide gas from its volcanoes, and this gas becomes ionized and drawn into the magnetosphere, forming an extremely dangerous radiation belt. Any spacecraft flying too close to Jupiter must be specially shielded against this radiation. Jupiter's magnetic field also produces the strongest auroras in the solar system. These auroras are hundreds of times brighter than those on Earth and can be seen in visible light, not just ultraviolet and X-rays. They are created by streams of charged particles from Io and from the solar wind, guided along magnetic field lines and colliding with the atmosphere at the poles. Not all meteorites that fall to Earth originate from the asteroid belt. Some come from the Moon and others from Mars. How do we know? By analyzing their chemical composition and comparing it with rock samples collected by space missions. Martian meteorites are ejected into space when asteroids or comets strike Mars with enough force. These fragments travel through space for millions of years, and eventually, some fall to Earth. Among more than 60,000 meteorites found on Earth, only about 200 have been identified as Martian. One of the most famous Martian meteorites is ALH 84001, found in Antarctica in 1984. In 1996, scientists announced that they had discovered structures in this meteorite that might be fossils of ancient Martian bacteria. The announcement shocked the scientific community and the public. Had we found evidence of extraterrestrial life? After years of debate and further research, most scientists now believe those structures can be explained by non-biological chemical processes. But the question remains open. AH84001 reminds us that Mars and Earth share a connected history, that material can travel between planets, and that if life ever existed on Mars, it might have left traces. We often think of the solar system as fixed in space, but in reality, it is moving at about 828,000 kilometers per hour. The entire solar system is orbiting the center of the Milky Way, taking about 225 to 250 million years to complete one orbit, called a cosmic year. As the solar system moves, it passes through different regions of the galaxy. Right now, we are traveling through a region called the local interstellar cloud, a diffuse cloud of gas and dust located inside a larger structure known as the local bubble. This bubble was created by supernova explosions millions of years ago, blowing out gas and forming a relatively empty cavity. The interstellar medium is not completely empty. It contains thin gas, dust, magnetic fields, and cosmic rays. As the solar system moves through different regions, the surrounding conditions change, potentially affecting the heliosphere and even the climate of planets. Some scientists have hypothesized that encounters with denser interstellar clouds in the past may have contributed to ice ages on Earth. We have talked about Saturn's rings, But interestingly, rings are not permanent structures. They can form and dissipate over time. Saturn's rings, although magnificent, may be only a few 100 million years old, very young compared to the age of the solar system. Rings can form when a moon is shattered by an impact or torn apart by a planet's gravity when it crosses the Roche limit. Inside this limit, tidal forces from the planet exceed the gravitational forces holding the moon together, causing it to disintegrate into a ring. Conversely, rings can also give birth to moons. Particles in a ring can gradually clump together over time, merging into small moons. In fact, some of Saturn's moons, called shepherd moons, move along the edges of the rings and keep them stable using their gravitational influence. Jupiter, Uranus, and Neptune also have rings, though they are much thinner and fainter than Saturn's. Earth does not have natural rings, but in the far future, if Phobos, the moon of Mars, continues falling toward its parent planet, it may break apart and form a temporary ring for Mars. Now, let us return to our home, Earth. Among all planets, Earth is the most special, not only because we live here, but because it has rare conditions that sustain life. Earth has a strong magnetic field generated by the flow of molten iron in its outer core. This magnetic field acts as a shield, protecting us from the solar wind and cosmic rays. Without it, radiation would gradually strip away the atmosphere and make the surface barren, as happened to Mars. Earth also has an axial tilt of about 23.5 degrees. This tilt creates the seasons. As Earth orbits the Sun, the northern and southern hemispheres alternately tilt toward the Sun, producing summer and winter. Without this tilt, the climate would be uniform year-round, but also more extreme, with hotter equatorial regions and colder poles. The Moon plays a crucial role in stabilizing Earth's axial tilt. The Moon's gravity keeps Earth's tilt from wobbling excessively. Mars, lacking a large moon, has an axial tilt that fluctuates dramatically over time, from 13 degrees to 40 degrees, causing extreme climate changes. The Moon also creates tides. Its gravity pulls on Earth's oceans, forming two bulges, one toward the Moon and one on the opposite side. As Earth rotates, these bulges move, causing two high tides and two low tides each day. Tides affect not only water, but also stretch Earth's crust itself, creating friction and heat. This friction slows Earth's rotation. A day on Earth is gradually lengthening by about 1.7 milliseconds per century. This seems tiny, but it accumulates over time. Around 400 million years ago, a day on Earth lasted only about 22 hours. At the same time, the Moon is slowly receding from us, about 3.8 centimeters per year. The reason is that Earth's rotational energy transfers into the Moon's orbital momentum through tides. In the distant future, the Moon will be so far away that it will no longer produce total solar eclipses. From Earth, it will appear smaller than the Sun, and when an eclipse occurs, we will see only a ring of light around the Moon's shadow. The Moon appears to be a dead world with no geological activity, but in reality, the Moon still has quakes, called moonquakes. Apollo astronauts placed seismometers on the Moon's surface, and these instruments recorded thousands of moonquakes over many years. There are 4 types of moonquakes. The first are deep moonquakes, occurring about 700 kilometers below the surface, likely caused by Earth's tidal forces. The second are shallow quakes occurring near the surface and stronger, possibly caused by the contraction of the crust as the moon cools. The third are thermal quakes, produced by extreme temperature changes between lunar day and night, causing rocks to expand and contract. The fourth are impact quakes triggered by meteoroid collisions. Moonquakes differ from earthquakes in that they last much longer. On Earth, an earthquake may last seconds to minutes. On the moon, a moonquake can last more than 10 minutes. The reason is that the moon is extremely dry and cold, making its rocks stiff and brittle, transmitting seismic waves more efficiently and for longer periods. The surface of the moon changes very little over billions of years. There is no wind, no water, no plate tectonics. The footprints of the Apollo astronauts remain intact and will persist for millions of years. Impact craters from the heavy bombardment era 4 billion years ago are still clearly visible. The moon is a historical record, preserving every collision and event from the distant past. In movies, we often see massive explosions in space accompanied by loud sounds. But in reality, space is completely silent. Sound requires a medium, air, water, or a solid, to travel through. In the vacuum of space, there is nothing to carry sound waves. This means that if you stood on the moon and shouted, no one would hear you, not even someone standing right next to you, unless they touched you or your spacesuits touched. Astronauts communicate using radios inside their suits. Planets and moons with atmospheres do have sound. On Mars, the atmosphere is much thinner than Earth's, so sound is weaker and travels more slowly. NASA recorded sound on Mars using a microphone on the Perseverance rover. You can hear the wind, the rover's wheels rolling over rocks, and even the Ingenuity helicopter flying. On Titan, the atmosphere is thicker than Earth's, so sound travels more efficiently. But because the atmosphere is composed mainly of nitrogen and methane, sound would likely be different from that on Earth, with lower frequencies. One of the greatest discoveries in recent decades is the realization that liquid water may exist beneath the icy surfaces of many moons. Europa, Enceladus, Ganymede, Callisto, Titan, and possibly even Triton may contain subsurface oceans. These oceans are unlike Earth's oceans. They lie deep beneath thick layers of ice, kilometers thick. No sunlight reaches them. The water is kept liquid by heat from the moon's core, generated by radioactive decay or tidal forces. If life exists in these oceans, it would be completely independent of sunlight. On Earth, most life depends on photosynthesis. But in Earth's deep oceans near hydrothermal vents, organisms survive using chemosynthesis, deriving energy from chemical compounds released from the interior. These vents are cracks in the seafloor where hot, mineral-rich water is expelled. Around them are rich ecosystems, including bacteria, giant tube worms, shrimp, and crabs, that thrive in total darkness. If similar hydrothermal vents exist on Europa or Enceladus, they may support extraterrestrial ecosystems. This is one reason scientists are so eager to explore these moons. NASA is planning the Europa Clipper mission, expected to launch in the 2020s to study Europa in detail and determine whether its subsurface ocean could support life. Magnetic fields do more than protect. They can also create hazards. The Van Allen radiation belts surrounding Earth are regions that contain charged particles trapped by the magnetic field. There are two main belts: the inner belt, located about 1,000 to 6,000 kilometers from Earth, and the outer belt, about 13,000 to 60,000 kilometers away. These belts contain high-energy protons and electrons that can be harmful to satellites and astronauts. Spacecraft must be designed to minimize the time spent passing through these belts, or be armored to protect against radiation. Jupiter has the strongest radiation belts in the solar system, as mentioned. Io continuously injects particles into Jupiter's magnetosphere, making the radiation belts extremely hazardous. NASA's Galileo spacecraft, which surveyed Jupiter and its moons from 1995 to 2003, experienced radiation doses 25 times higher than its original design specification. Ultimately, radiation damaged many of the spacecraft's systems. For decades, astronomers have searched for a large undiscovered planet beyond Neptune. Pluto was once thought to be that planet, but when discovered, it was too small. Eris was also not large enough. But recent studies suggest there may indeed be a truly large planet lurking at the distant edge of the solar system. Evidence comes from the orbits of distant Kuiper Belt objects. Some of them have very eccentric and unusually aligned orbits, as if being shepherded by a large unseen body. Astronomers Konstantin Batygin and Mike Brown proposed in 2016 that there may be a planet 5 to 10 times the mass of Earth, orbiting the Sun with a period of 10,000 to 20,000 years. If Planet 9 exists, it would be an icy, frigid world so far from the Sun that sunlight there would be as faint as moonlight on Earth. Observing it would be extremely difficult because it would be distant and dim. But new telescopes, such as the Vera C. Rubin Observatory, under construction, may be able to find it in the coming years, if it truly exists. Voyager 1 and 2 are not only exploration machines, they are emissaries of humanity. Each spacecraft carries a golden record containing sounds and images representing the diversity of life and culture on Earth. The record includes 116 images showing humans, animals, plants, landscapes from around the world, as well as scientific diagrams of DNA, atomic structure, and the location of Earth in the solar system. There is an image of a human hand, an image of a mother nursing a child, an image of traffic in a city, and an image of ocean and coastline. Besides images, the record includes natural sounds: surf, thunder, wind, bird song, frog calls, and whale song. There are human sounds: kissing, children laughing, footsteps, and a heartbeat. Both records also include a message from President Jimmy Carter. This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so that you may live in yours. Voyager 1 is now more than 24 billion kilometers from Earth and continues to travel outward at about 61,000 kilometers per hour. In roughly 40,000 years, it will pass near the star Gliese 445, 17.6 light-years away. Will anyone find it? Will they understand the message? We do not know. But the Voyager, golden records, are evidence that we were here, that we looked up at the stars and dreamed. We have traversed the entire solar system, from the extreme heat of the sun's core to the frigid reaches of the Oort cloud. We have seen giant planets and tiny moons. We have learned about winds, storms, volcanoes, subsurface oceans, and rings. We have studied magnetic fields, orbits, and the laws that govern motion. The solar system is a place of wonder and mystery. Each planet and each moon has its own story. And we, the small humans on the blue Earth, are part of that story. We have visited every planet and seen the sun and its mysteries. Yet the question remains, lingering in our minds. Where does the solar system end? And what lies beyond that boundary? The invisible boundary. When we think about the boundary of the solar system, we often think of Pluto, or perhaps the Kuiper Belt. But the reality is far more complex. The solar system has no single sharp border, like a political boundary on a map. Instead, it has many boundaries, depending on how you define it. If you define the solar system by the sun's gravity, the boundary extends much farther than any spacecraft we have sent. The sun's gravity influences objects at distances of light years, including the Oort cloud, the birthplace of long-period comets. But there is another boundary, closer and more relevant to our understanding of interstellar space. It is the boundary of the solar wind, the region where the sun's influence ends and interstellar space begins. This boundary is called the heliopause. The sun emits not only light and heat, but also a continuous flow of charged particles called the solar wind. These particles, mainly protons and electrons, are expelled from the sun's corona at speeds of hundreds of kilometers per second. They do not stop at any planet. They stream outward, past all the planets, through the Kuiper Belt, and beyond. The solar wind blows in all directions, forming a gigantic bubble that surrounds the entire solar system. This bubble is the heliosphere. Inside the heliosphere, we are partially shielded from cosmic rays originating in interstellar space. The sun's magnetic field, carried by the solar wind, deflects some cosmic rays and reduces their intensity inside. But the solar wind cannot blow forever. Eventually, it collides with the interstellar medium, the space between the stars. The interstellar medium is not empty. It contains thin gas, mostly hydrogen and helium, dust, magnetic fields, and cosmic rays. The pressure of the interstellar medium pushes back against the solar wind, creating a boundary. This boundary, the heliopause, is where the solar wind no longer has sufficient strength to push back the interstellar plasma. It is the true edge of the sun's influence, the border between the region dominated by the sun and true interstellar space. The heliopause is not a sharp wall. It is a transition region, millions of kilometers wide, where the solar wind slows and mixes with interstellar plasma. Its exact position changes over time, depending on solar activity and the pressure of the surrounding interstellar medium. Before reaching the heliopause, the solar wind must cross a region called the termination shock, where the solar wind suddenly slows from supersonic to subsonic speeds. Like a jet crossing the sound barrier and producing a sonic boom, the solar wind creates a shock when it slows. Beyond the termination shock lies the heliosheath, where the solar wind is slow and turbulent before finally meeting the heliopause. For more than 4 decades, 2 small spacecraft have traveled farther than any other human-made objects. Voyager 1 and Voyager 2 were launched in 1977 with the original mission to survey the giant planets, Jupiter, Saturn, Uranus, and Neptune. They completed that mission brilliantly, sending back thousands of images and invaluable scientific data. But after completing their primary missions, the Voyagers did not stop. They continued outward into unexplored regions of the solar system. NASA extended their mission as the Voyager Interstellar Mission to study the outer reaches of the solar system and ultimately interstellar space. In December 2004, Voyager 1 crossed the termination shock at about 94 astronomical units from the Sun, 94 times the distance from Earth to the Sun, roughly 14 billion kilometers. Its instruments detected sudden changes in the speed and temperature of the solar wind. It entered the heliosheath. Voyager 2 followed, crossing the termination shock in August 2007 at a somewhat closer distance than Voyager 1. This shows that the heliopause is not perfectly symmetric, possibly distorted by the solar system's motion through the interstellar medium. For years, scientists waited for the next sign, the indicator that the spacecraft had crossed the heliopause. They did not know exactly what it would look like. They only knew there would be changes in plasma, magnetic field, and cosmic ray measurements. On August 25, 2012, Voyager 1 achieved what no human-made object had done before. It crossed the heliopause and entered interstellar space. Scientists observed a sudden increase in electron density, a signature of interstellar plasma. Cosmic ray intensity also rose sharply, while the density of solar wind particles dropped to nearly zero. Voyager 1 had left the solar system in the sense of the heliopause. It is traveling through interstellar space, though still subject to a tiny influence from the Sun's gravity. 6 years later, in November 2018, Voyager 2 also crossed the heliopause at about 119 astronomical units from the Sun. Unlike Voyager 1, some of Voyager 2's scientific instruments were still operational, allowing direct measurements of interstellar plasma. These measurements confirmed Voyager 1's indications. Interstellar space is denser, colder, and richer in cosmic rays than inside the heliosphere. Currently, Voyager 1 is more than 24 billion kilometers from Earth and moving at about 61,000 kilometers per hour. Voyager 2 is about 20 billion kilometers away and moving at roughly 55,000 kilometers per hour. Signals from Voyager 1 take more than 22 hours to reach Earth, even traveling at the speed of light. Both spacecraft continue to send data, although their power sources, radioisotope thermoelectric generators, are slowly decaying. Each year, they lose about 4 watts of power. NASA engineers have had to switch off non-essential instruments to extend the missions. It is expected that by the mid-2020s or early 2030s, The Voyagers will no longer have enough power to operate scientific instruments. They will then fall silent and continue drifting through interstellar space for thousands to millions of years. Each Voyager carries a special legacy of humanity, the Voyager Golden Record. These are gold-plated copper discs, 30 centimeters in diameter, designed to survive for billions of years in the harsh environment of space. Each record contains sounds and images representing the diversity of life and culture on Earth. The idea of the Golden Record was proposed by Carl Sagan, the astronomer and science communicator. Sagan and a team of experts carefully selected the record's content in a very short time, just a few months before the Voyagers were launched. The record contains 116 images encoded in analog form, showing humans, animals, plants, and landscapes from across Earth, as well as scientific diagrams of DNA, atomic structure, and Earth's location in the solar system. There is an image of a human hand, a mother breastfeeding a child, traffic in a city, and oceans and coastlines. In addition to images, the record contains natural sounds: surf, thunder, wind, bird songs, frog calls, and whale songs. There are human sounds: kissing, children laughing, footsteps, and a heartbeat. The record also contains music from many cultures and periods. There is Bach's Brandenburg Concerto No. 2, Beethoven's Symphony No. 5, gamelan music from Java, folk songs from Peru and Bulgaria, and Chuck Berry's Johnny B. Good. In total, there are 27 musical selections, representing the richness and diversity of human music. There are greetings in 55 languages, from ancient Sumerian to modern languages such as English, Chinese, Vietnamese, and Swahili. Each greeting is simple and warm, like "Hello to our friends" or "Peace and happiness to all people." U.S. President Jimmy Carter wrote a message engraved on the record's cover. "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so that you may live in yours. We hope that one day, after we have solved the problems we face, we may join a community of galactic civilizations. This record represents our hope, our determination, and our goodwill in a vast and wondrous universe." Kurt Waldheim, then Secretary General of the United Nations, also contributed a message. "As this spacecraft leaves the solar system and ventures into the universe, it speaks for humanity. We step out of our time into your time with hope." The chance that an extraterrestrial civilization will find the Golden Record is extremely small. Space is vast and mostly empty. The Voyager spacecraft are tiny and do not emit strong signals. They are traveling through interstellar space where stars are separated by light years. Voyager 1 is heading toward the constellation Ophiuchus. In roughly 40,000 years, it will pass near the star Gliese 445, 17.6 light-years away. But near in space still means about 1.6 light-years, an enormous distance. Voyager 2 is heading toward the constellation Sagittarius and will pass near the star Ross 248 in roughly 40,000 years. Yet the significance of the Golden Record is not only its chance of being found, it is a symbol of humanity's hope and ambition. It says, We are not confined to Earth. We can reach for the stars. It is a message to the future, evidence that we existed, that we loved, created, and dreamed. Carl Sagan wrote, "Spacecraft will be intercepted, and their records played only if there exists an interstellar civilization." But sending this message is an act of hope for humanity's future. We believe that one day, millions or billions of years from now, this message may be played. If no one else hears it, it will remain as a legacy of our world, a world that may one day vanish. Voyager 1 and 2 now travel in interstellar space, but that space is not the complete void we might imagine. It contains a thin but complex environment of gas, dust, magnetic fields, and cosmic rays. The density of interstellar gas is very low, about 0.1 atoms per cubic centimeter, compared with roughly 10 to the power of 19 molecules per cubic centimeter in Earth's atmosphere at sea level. Yet across vast volumes, even this tenuous gas matters. Interstellar gas is mostly hydrogen and helium, the legacy of the Big Bang, along with trace heavier elements formed in stars. Interstellar dust also exists, tiny particles produced in the atmospheres of old stars or in supernova explosions. This dust absorbs and scatters starlight, creating dark nebulae visible in astronomical images, such as the Horsehead Nebula. Interstellar magnetic fields are much weaker than planetary or solar fields, but they still influence the motion of charged particles. Cosmic rays, high-energy particles from distant sources such as supernovae, pulsars, or other galaxies, traverse interstellar space, bent by magnetic fields and interacting with gas and dust. Voyager discovered that interstellar space is not quiet or homogeneous. It has structure and variability, denser and rarer regions, hotter and colder zones. Plasma waves, oscillations in the ionized gas, propagate through space, driven by energetic events such as eruptions on the Sun or other stars. One of Voyager's most intriguing findings is the interstellar hum of plasma. Voyager 1's instruments detected weak plasma waves oscillating continuously at very low frequencies. Scientists converted these waves into sounds audible to humans. The result is a faint, almost monotonous tone with subtle variations. The song of interstellar space, a music no human ear can hear directly, but whose existence we can now know. We often think the sun and planets are fixed, but in fact, the entire solar system moves through space at astonishing speed. The solar system orbits the center of the Milky Way at about 828,000 kilometers per hour, or roughly 230 kilometers per second. The Milky Way is a giant spiral galaxy containing hundreds of billions of stars. The Sun resides in a spiral arm called the Orion Arm, about 26,000 light-years from the galactic center. At this distance, it takes the Sun roughly 225 to 250 million years to complete one orbit, a cycle called a cosmic year or galactic year. This means that since Earth formed 4.6 billion years ago, the solar system has orbited the galaxy about 20 times. The last time we were at our current galactic position was about 225 million years ago, in the late Triassic period, when dinosaurs were beginning to evolve and the continents were still assembling into the supercontinent Pangaea. The solar system's motion through the galaxy is not a simple circle. It also oscillates above and below the galactic plane like a horse on a carousel. This cycle takes about 70 million years. Currently, we are moving upward relative to the galactic plane and will reach the maximum height in roughly 15 million years. Some scientists have proposed that this oscillation might affect Earth. When the solar system passes through denser galactic regions, it may encounter more dust, gas, and objects, potentially altering the interstellar environment around us. One hypothesis links some mass extinction events to times when the solar system moved through higher density regions, increasing the likelihood of comet or asteroid impacts on Earth. However, evidence for this idea remains debated. Besides orbiting the galaxy, the Milky Way itself is moving. It is approaching the Andromeda Galaxy at about 110 kilometers per second. In roughly 4 to 5 billion years, the two galaxies will collide and merge into a larger galaxy, playfully dubbed Milkomeda. But there is no need to worry. This process unfolds over billions of years. And even during a galactic collision, the distances between individual stars are so vast that direct stellar collisions are extremely unlikely. The solar system does not move through empty space. It passes through a structure called the local interstellar cloud, a region of diffuse gas and dust inside a larger structure called the local bubble. The local bubble is a relatively empty region about 1,000 light-years across, created by a sequence of supernova explosions millions to tens of millions of years ago. These explosions cleared out gas and dust, forming a low-density bubble. Within this bubble are smaller clouds. The local interstellar cloud is one of them. The local interstellar cloud has a temperature of roughly 6,000 to 7,000 Kelvin, seemingly hot, but so tenuous that it cannot transfer heat effectively. Its density is about 0.3 atoms per cubic centimeter, slightly higher than the average within the local bubble, but still vanishingly thin by terrestrial standards. The solar system is moving through the local interstellar cloud at roughly 26 kilometers per second relative to the cloud. We have been within this cloud for about 44,000 to 150,000 years and will exit it in roughly 10,000 to 20,000 years, depending on the cloud's exact size. As the solar system traverses different galactic regions, it encounters varying interstellar environments. Sometimes, we may pass through denser clouds where gas and dust concentrations are higher. This can compress or reshape the heliosphere. Some researchers suggest such changes could affect Earth's climate by altering the flux of cosmic rays that reach our atmosphere. Cosmic rays can influence cloud formation by ionizing air molecules, creating condensation nuclei for water vapor. More cosmic rays might produce more clouds, which could cool Earth by reflecting sunlight back to space. This is an active research area, and the precise relationship between cosmic rays and climate remains under debate. Although Voyager 1 and 2 have crossed the heliopause, they have not truly left the solar system in the gravitational sense. The Sun's gravitational influence extends far beyond the heliosphere. The true gravitational boundary of the solar system is the Oort cloud, a vast spherical shell containing trillions of icy comets. The Oort cloud is thought to begin around 2,000 astronomical units from the Sun and extend to roughly 100,000 astronomical units, nearly 1/4 of the distance to the nearest star, Proxima Centauri. To put this in perspective, Voyager 1 is currently about 165 astronomical units from the Sun. It will take thousands of years to reach the inner edge of the Oort cloud and tens of thousands of years to traverse it. The Oort cloud has never been observed directly. It lies too far away, and its objects are too small and dark for current telescopes. Its existence is inferred from the orbits of long-period comets that take thousands or millions of years to complete an orbit. Objects in the Oort cloud are relics of the solar system's formation. Icy and rocky bodies formed in the primordial disk around the young sun, later scattered outward by the giant planet's gravity, especially Jupiter and Saturn. At such distances, the sun's gravity is weak, barely keeping objects in loosely bound orbits. Passing stars or galactic tides can perturb the Oort cloud, sending objects inward as long-period comets. In the distant future, if faster spacecraft are developed, we may send missions to explore the Oort cloud. With current technology, it remains out of reach. It is the final frontier of the solar system, the place where the sun's influence fades and true interstellar space begins. Beyond the solar system, the nearest star is Proxima Centauri, a small red dwarf in the Alpha Centauri system, about 4.24 light-years away. At Voyager 1's current speed, it would take over 70,000 years to reach it. But Voyager is not aimed at Alpha Centauri, so it will never approach it. Proxima. Centauri has at least 2 confirmed planets. One of them, Proxima Centauri b, lies in the habitable zone where temperatures could allow liquid water on the surface. It is among the nearest and most intriguing exoplanets in the search for life. However, Proxima Centauri is an active star that emits powerful flares and charged particles. This could make the environment around its planets hostile to life as we know it. If Proxima Centauri b has an atmosphere and magnetic field, it could be partially protected. If not, its surface could be constantly bombarded by radiation. Other nearby stars include Barnard's star at 6 light-years and Wolf 359 at 7.9 light-years. Within 30 light-years, there are roughly 400 stellar systems, most of them red dwarfs, small, faint stars with very long lifetimes. These stars are our neighbors in the galaxy. Yet even the nearest neighbors are separated by unimaginable distances. The spacing between stars is enormous relative to their sizes. If the Sun were the size of a golf ball, Earth would be a grain of sand about 2.5 meters away. The nearest star, Proxima Centauri, would be another golf ball some 625 kilometers distant. Space is vast and mostly empty. This is why interstellar travel is such an enormous challenge. Even with our fastest current spacecraft, it takes tens of thousands of years to reach another star. To truly explore the stars, we will need new technologies, perhaps nuclear rockets, advanced ion drives, or even light sails propelled by terrestrial lasers. Voyager 1 and 2 will not be the only spacecraft to leave the solar system. 3 others are also on trajectories outward: Pioneer 10, Pioneer 11, and New Horizons. Pioneer 10 and 11 were launched in the early 1970s, before the Voyagers. They were the first spacecraft to survey Jupiter and Saturn. Both lost contact with Earth many years ago, but they continue to drift outward. Pioneer 10 is heading toward the constellation Taurus and will pass near the star Aldebaran in about 2 million years. Pioneer 11 heads toward Aquila. Each Pioneer carries a metal plaque engraved with images of a man and a woman and a diagram indicating Earth's position relative to nearby pulsars. These plaques are precursors to the Voyager Golden Record, a simpler but meaningful message. New Horizons, launched in 2006, is the fastest spacecraft ever to depart Earth. It flew past Pluto in 2015, returning the first close-up images of that dwarf planet and its moons. It then flew by Arakoth, a Kuiper Belt object, in 2019. Currently, New Horizons is continuing to fly outward and can be used to study the environment of the Kuiper Belt and possibly interstellar space. It will likely cross the heliopause around the 2040s or 2050s, if it still has power and remains operational. New Horizons also carries a portion of the ashes of Clyde Tombaugh, the astronomer who discovered Pluto in 1930. In the future, there may be dedicated missions to study interstellar space. NASA has studied the concept of the Interstellar Probe, a spacecraft specifically designed to reach the heliopause faster and with more scientific instruments. The goal is to reach the heliopause within 15 to 20 years after launch, compared to more than 35 years for Voyager. To accomplish this, the spacecraft would need to be much faster. One possibility is using the Oberth effect, flying very close to the Sun to take advantage of its gravity and accelerate. Another possibility is using nuclear rockets or other advanced propulsion systems. The Interstellar Probe could carry instruments to measure magnetic fields, plasma, dust, and cosmic rays in interstellar space. It could help us better understand the environment the solar system is moving through and how that environment affects us. For thousands of years, humans have looked up at the night sky and wondered what lies beyond. We have created stories about the stars, formed constellations, and dreamed of reaching them. Only in the past century have we turned those dreams into reality. We have sent humans to the moon. We have sent robots to every planet in the solar system. And now, we have sent our emissaries into interstellar space. Voyager 1 and 2 are proof of the human spirit of exploration. They were built with the technology of the 1970s, with computer memory far less than that of a modern smartphone. Yet they still operate, still send data, still continue their mission after more than 45 years in space. They are symbols of what we can achieve when we work together, when we dare to dream big, when we are not afraid of failure. Voyager has faced countless challenges: radiation, extreme cold, micrometeoroids, software errors, and the aging of its equipment. But engineers and scientists have found ways to overcome each problem, keeping the spacecraft operating far longer than originally expected. Every signal from Voyager Every bit of data sent back across billions of kilometers of space is a triumph of human intelligence and perseverance. And the message the spacecraft carry, the golden record, is a declaration of our values, that we cherish the beauty, diversity, and wonder of life, that we hope for a future in which we are no longer alone in the universe. When Voyager 1 was at a distance of 6 billion kilometers from Earth on February 14, 1990, it turned back and took one final picture of our planetary system. Among those images was a picture of Earth, which Carl Sagan called the pale blue dot, a pale blue speck. In the image, Earth is just a tiny point of light, less than a pixel, floating in a ray of sunlight reflected into the camera. That is all we are when viewed from the edge of our own solar system. Carl Sagan wrote about this photo. Look again at that dot. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of all our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. This image reminds us of the fragility and preciousness of the planet we live on. It reminds us that we share this small home and that we must take care of it. There is no other place, at least in the near future, where we can move to. Earth is the only place we have. And now, as we conclude this journey, imagine once again those tiny spacecraft, Voyager 1 and 2, drifting in the silence of interstellar space. They are flying through an unimaginably vast, cold, and dark expanse. There is no sunlight strong enough to warm them. There is no air to carry sound. There is only absolute silence. But they are not entirely alone. They carry a part of us, a tiny piece of humanity. The golden record, with sounds, images, and messages from Earth. They are our ambassadors, representing the best in us, and perhaps one day, in the unimaginably distant future, another civilization will find one of these spacecraft. They will take the golden record, decode it, and hear our voices. They will know that once, on a small planet orbiting an ordinary star, there was a species that looked up at the stars and dreamed. Whether that happens or not, the Voyagers have fulfilled their mission. They have shown us new worlds, expanded our understanding of the solar system and farther space, and inspired millions with the spirit of exploration. Take a deep breath. Feel the peace. You are lying on Earth, our small blue planet, gently rotating in space. Surrounding you is the fragile atmosphere, protecting you from the harshness of space. Above, the stars are shining, each one a sun with its own worlds, its own stories. And somewhere out there, farther than all that the eye can see, the Voyagers are continuing their journey, carrying our message to the stars. They are proof that we were here, that we were curious, that we loved and dreamed. Now, close your eyes, breathe deeply and slowly. Imagine yourself floating in space, looking down at Earth from afar. You see the blue of the ocean, the green of the forests, the white of the clouds and ice. You see the city lights twinkling in the dark. You see the moon, our silent companion. And farther still, you see the other planets, Earth's siblings, each with its own beauty and mystery. You see the sun, the heart of it all, bright and warm. You are a part of this universe. Every atom in your body was forged in the heart of stars billions of years ago. You are stardust. You are the universe looking back at itself. And tonight, as you drift off to sleep, know that you are safe. The earth is gently spinning. The moon is high. The stars are shining. And the universe, vast and mysterious, is still out there, waiting to be explored. Sleep well in the embrace of the night sky. Before we end, I would like to express my sincere thanks to pixabay.com for providing such wonderful free images that helped me create this video. If you found this content relaxing and enjoyable, don't forget to subscribe to the channel 5 Minutes Fall to Sleep. Give this video a like and leave a comment to let me know you're here. Your support is the motivation for me to keep creating more gentle and soothing content. And now, just relax, close your eyes, and let sleep gently come to you. Wishing you a very peaceful night's sleep.